this question is that timer-related question I alluded to earlier. So in this case, we have two interrupt routines. We have a GPIO and a timer interrupt routine. And the timer interrupt, and both of these routines are presumably invoked by something else. We don't really need to go into detail of like who calls these routines, but just to know that there are two routines, two functions that can be invoked at arbitrary points in time. And we are being told that the timer routine, the timer callback, timer function is being invoked every 100 milliseconds. And then the GPIO routine occurs at some sort of indeterminate interval. So that's kind of the first piece of information that we're given. The next thing that we're told, the thing we're being asked to do is when the GPIO interrupt occurs for the first time, we want to start a timer. It doesn't say how we go about starting a timer or what it means by a timer, but we would need to start a timer, a countdown timer of sorts. And we want to start that timer because if 3 GPIO interrupts occur within 1 minute of the first interrupt occurring, then we want to call func A. If an entire minute goes by after the first GPIO interrupt, if an entire minute goes by and 2 more interrupts haven't occurred since, then we call func B. So that is the premise. And because we're running a little bit low, let me just, rather than talk about it conceptually, let me just share some kind of quick code that I wrote up that was kind of my initial instinct for how I would potentially solve this problem. And let me first call out the couple pieces of kind of global state that I think we need for bookkeeping purposes. The first thing I have is an atomic variable, an atomic 64-bit variable that represents the current time. Not the current like wall time, but the current time with respect to this interrupt routine or these interrupt routines. So it starts at 0 and it increments from there. And then what I also have is an array of 3 GPIO times. So each time a GPIO interrupt occurs, I'm going to save the time at which it occurred in this array. And technically speaking, I probably could have just made it an array of length 2, but I don't know. I wasn't thinking it entirely through, and I made it length 3 for simplicity. And then the final thing I have is another atomic variable that is the index into this array that is effectively a right pointer, like where the next GPIO event will be inserted. So initially it would go into the 0th entry, then the 1st, and then the 2nd. So that's kind of my state that I've defined here. The assumption that, once again, I'm making is that someone is calling this timer function, this timer interrupt routine, someone's calling it once every 100 milliseconds. And I don't need to do anything to get that started. It just happens. And then this is the GPIO routine that happens at whatever period of time it might be. For me, what I do here now is let me take first step back. That's kind of my setup. Now I need to handle the case, let me jump back over here, when the GPIO interrupt occurs, start the timer. So what I do to logically start the timer is I store the current time in the first entry in that array. And then I atomically increment that array, or this right index, by 1. And I check, have I received, is this the 3rd one that I've received? Am I on the number 3? If I'm on the number 3, then call func A and reset all those statistics. within the timer operation, every time the timer callback is invoked, I incremented the current time by 1. And I know this is invoked every 100 milliseconds, but all I really care about is whether or not something occurs after 1 minute. And I don't need millisecond precision for that purpose. So I am storing this time in deciseconds because that makes my life easier. So every time the timer interrupt is invoked, I increment my current time by 1, and then I check whether or not is my current index non-zero. And I guess to be fair, I probably should have done an atomic load here. Is my current index non-zero? If it is non-zero, look at the current time relative to the time that it was at the first GPIO interrupt. And if that difference is greater than 1 minute or 600 deciseconds, call function B and reset the statistics. There is a potential problem in this code that we can talk about in just a second. But any questions at the moment with regards to this? Or concerns or suggestions or maybe alternative better ways of doing it? Also open to hearing from folks.
One question I had was, we are doing set statistics, but what happens if the interrupts happening continuously? So are we supposed to?
I'm sorry, Ankit, you're very quiet. I can't hear most of the words you're saying.
So one question I had was that, for example, because we received GPIO interrupts like 0, 1, 2 within 1 minute, and then we call function A. But here we are doing reset. But what if we receive a GPIO call like 3, but that happens within 1 minute of 1 to 3? Like not from 0, but 1 to 3 are also within 1 minute. So do we say again? Because if we are resetting statistics, that means whatever the next GPIO interrupt occurs, we have to restart the timer from 0.
So, well, this is here's the prompt once again. And see, this prompt doesn't actually say it needs to support multiple iterations. I'm just kind of assuming that we wanted to support multiple iterations. But note, what we're doing here is checking the current time relative to the first time is greater than 1 minute. So once this has gone through one iteration and we've called func A or func B, and then we reset the statistics, well, it doesn't really matter which set of statistics we reset. We could reset current time and reset these guys, or we could keep current time continuously incrementing and just reset these statistics. But the end result is that the next time the GPIO fires, we will increment that index. Oops, I left out X right there. Increment that index by 1, which would now allow this code to potentially pass. And we would store the value of the current time in that first entry, allowing this check to then be valid, if you will. So feel free to say your concern again, but I think I've covered the issue of having this occur multiple times. It's also possible I misheard you because I was having a bit of a hard time hearing all the words. Okay, so maybe I'll point out the one issue with this current code. And I'll be honest, I didn't think about this until I reread the code right now, which is we need to make sure either func A or func B is called. We can't ever call both. We have to call one or the other. And in this code, as it is right now, there's an edge case where these two, once again, if we assume that two interrupt routines can occur simultaneously, and nothing in the prompt says that these two interrupts can't occur simultaneously, then it would be plausible for this condition to pass and call func B prior to resetting the stats, such that this condition then is reached and we call func A before resetting the stats. So what we need is a way to ensure that either func A or func B is called, not both of them. And my initial thought, and I have to think about this more a little bit, is either we can do some reordering of the atomic operations, and we might be able to guarantee only one or the other occurs after that reordering, or we'll need to use a compare and swap operation to ensure that only one of these two ends up being invoked. The most trivial way of doing that is inside of this if check, for instance, do a compare and swap on some sort of variable that indicates whether or not func A or func B has occurred, such that if we get to the point where func A and func B are both about to be called, then we can only do it for one. So that would be at least two potential solutions. And I need to look at this for another minute to see whether or not we could reorder these operations, reorder these atomic operations to make sure that only one of them would ever be invoked. But since we're almost out of time, I might not do that right now. But any other questions about this? And I forget who submitted this question. Anki, this was your question. Okay, that makes sense why you were asking the follow-up questions then. So feel free to speak up now if maybe I misunderstood the question, or if you had a different idea in mind that you would like to be.
Yeah, this was quite long ago, so I didn't remember the question. But this is what I remember.
You know, I am very sorry, Anki. I still can't hear most of the words that you're saying. So I don't want to just ignore you. So maybe a better option might be to use the Q&A box if you have something you want to say to make sure it gets communicated. So sorry about that. I don't know what the problem is. I can hear everyone else just fine. It's just the problem with you. But feel free to write in the Q&A box and we can do that. But while Ankit is doing that, any other questions, concerns about this sort of solution or question? And I guess it's once again worth stating out loud, if only a single interrupt routine is capable of being invoked at a time, which is potentially a reasonable assumption, then we wouldn't need to bother with any of this atomic stuff. Because the whole point of these atomics is to have synchronization between these two interrupt routines if they do occur simultaneously. But if they can't occur simultaneously, then we can have all the exact same code, just sans the atomic portion of it.
Sorry. So even if they occur simultaneously, there will be some kind of a priority, right?
That would be a reasonable assumption, and that could be an assumption that you could state out loud in the interview that, hey, I'm going to assume that the GPIO interrupt routine will run to completion prior to the timer interrupt running, and one interrupt routine won't preempt the other interrupt routine. Like you could make that sort of claim, but I don't think it is necessarily a universally true statement. Like I could come up with a contrived example where these interrupt routines could be called simultaneously and the processor could swap between these two. Or you might be running on a system that has multiple hardware threads or multiple processors, and different processors might be handling different interrupt routines.
Okay, yeah. No, that I think, yeah, that is more general.
That's
yes.
kind of, I thought, frankly, this question was a bit too simple if we didn't have at least some sort of concurrency concern. So I figured I might as well try and take a stab at the more complicated solution. So thank you, Ankit. So if GPIO call 0, 1, 2 occurs within 1 minute, we call func A. cool. But if GPIO ISR call 3 happens again within 1 minute of GPIO 1, but not 0, do we need to call func A again? And I suppose these are potentially two different interpretations of the question posed. Here, when I read this line, I was particularly focused on this else. Like, we call func A or else we call func B. So there's never a scenario in which case we call A and B. That being said, I think your question alludes to a different interpretation of this prompt, where if the 3 GPIO call happens within one minute, we call func A, and after a minute elapses, regardless of whether we call func A, then we always call func B. That could be a different interpretation. I don't want to make a claim for which interpretation is correct. This would be the kind of thing that you might want to ask the interviewer to make sure that you understand that it is a this or that, as opposed to a this and or that. And as you point out, if this was a and or, then we would not want to reset the statistics here. We would not want to reset the statistics there. We would only want to reset the statistics after 1 minute has elapsed down here. Or maybe it's the other way around. In whichever way you interpret this question, you could reset the statistics in one case versus the other. The way I read this question was a strict else, but this is where very small changes in the prompt can have significant impacts on the code that you design and implement. And if you have the interviewer right there in front of you, it's worthwhile to ask these questions of the interviewer to make sure you're on the same page. Obviously, when I did this, I had no one to talk to, so I made some hopefully reasonable assumptions. But if you have that person right there on the phone with you or right there in the room with you, those would be clarifying questions that would be worthwhile to ask prior to you going about implementing much of anything.